In the previous Homework 9 video, I went over the first two rules of exponents, one of them being the product rule when you're multiplying and exponents get added. And then the second one was called the power rule, which was when we had two exponents but only one base and we ended up multiplying the exponents. So far we've looked at problems where exponents are added and exponents are multiplied. In this first rule up at the top here, it's called the quotient rule, which is a rule of division. And through division, the rule is that just like multiplication, you were able to add the exponents, while with division, you're able to subtract the exponents. I'm going to do some examples with that in a few minutes, but I do want to address the rule of negatives before I do that, because although Alex doesn't address it until a little bit later on, I do think it helps if you see how negative exponents work, because sometimes when you're subtracting, if you use this rule, you end up with a negative exponent and you need to know how to handle it. So in math, there is not an allowance for negative exponents. So what you do is, in this example, this is just using letters, but let's say I have a to the negative m. What you're able to do is put this over 1 and take the reciprocal or flip it over. And when you flip it over, it becomes 1 over a to the m. So if it's a negative m in the numerator, when you move it to the denominator, it becomes positive. So let's look at a few examples. If I have 3 to the negative 2, I can't have that negative exponent, so I'm going to put it over 1, and then I'm going to flip it over. The 3 to the negative 2 goes to the denominator as 3 squared, and I end up with 1 over 9. In the second example here, I have a negative exponent in the numerator and in the denominator. So whenever you have a negative in both locations, to remove the negative, you always take it from its location and move it to its opposite location. So if it's in the numerator, which it is here, I'm going to take it and put it in the denominator. And because this is negative in the denominator, I'm going to take it and move it up into the numerator. And all I'm doing is removing exponents. There's nothing else I can solve at this point. In this one right here, I wanted to address the negative 2. A lot of times I'll see students say, oh look, x to the negative 1, we can't have that, so let me move it to the bottom. Which is correct. When it moves to the bottom, it becomes a regular 1 though, not a negative. So it's just x to the first. Sorry, I didn't mean to put a dot there. Actually, just going to get rid of that altogether because x to the first is technically just x. The x to the fourth is going to stay in the bottom with it because x to the fourth is a positive 4, so you don't need to move it to the numerator. The only time you would move an exponent is if the exponent is negative. If it's already positive, it's going to stay right where it is. Now, a lot of times I'll see students move the negative 2 down to the denominator as well, but you wouldn't want to do that in this case because remember, this rule of negatives only applies to exponents, and this is not an exponent, this is a regular negative 2. Now, it does have an exponent that you don't see, but the exponent that it has that you don't see is a 1. So the negative 2 in this problem would stay in the numerator. The x would go to the bottom, and the x to the fourth would stay in the bottom. And the only other thing you could do here as your final answer is make the denominator x to the fifth, because remember, when you have x to the fourth and x to the first, these are touching, which means they're being multiplied, and the shortcut we learned is through multiplication they end up getting added. And then in this very last one, I just wanted to address that there's technically ones here, and that this is an example of power to a power. So the first thing I would need to do here is remember that whenever I have an exponent raised to another exponent, I multiply. So this becomes 3 to the negative 2 over 4 to the negative 2. But I can't leave the negative exponent, so I'm going to flip the whole thing over, making it 4 squared over 3 squared. I moved the 4 up and the 3 down, making the exponents positive. And my final answer, if I do the math out and actually square the numbers, I end up getting 16 over 9 because I know 4 squared is 16 and 3 squared is 9. So that's just a quick review of negatives. I'm going to use that with the division property. So just remember, when we're doing rules of exponents, the only time you're allowed to have a negative exponent, which you'll see in the next video I make, is when we're doing scientific notation. So let's take a look at some division examples. I'm going to start over here with number 1. 5 over 20. I can reduce because I know that both 5 and 20 are divisible by 5. 5 goes into itself once. I don't really need to write the 1, but I'm going to write it just to show you for this video. And 20 and 5 goes into 20 4 times, just like that. the x's cancel out because whenever you have something divided by itself, remember that it becomes a 1, so I no longer need it. And the w is going to stay on the top and the y is going to stay on the bottom. Now Alex would prefer that you enter this answer without the 1 next to the w. I'm going to scribble that out there. W over 4y. However, if you forget and you put the 1 into Alex, it will still mark it correct and just suggest that you don't use it. Let's take a look at another example, and I'm going to show you 2 ways to do number 2. First, I'm going to do 40 divided by 4, which comes out to be 10. And then I'm going to use the rule of division here. And this is the reason why I try to teach the negative rule at the same time, because what you're supposed to do in this problem is you're supposed to subtract the exponents through division. So 4 minus 7, I end up getting x to the negative third. And that's a problem, because in math we cannot have negative exponents. But I subtracted, that's what I'm left with. 40 over 4 is 10, 4 minus 7 is negative 3. So to fix this, what I would need to do is put it over 1. I keep the 10 in the numerator, and the reason I'm keeping the 10 in the numerator is because technically there's a 1 there. It does not move down. It's the x that has a negative exponent, and only the x would move to the bottom. And this would be your final answer. So what happened was I subtracted because that's the rule of division. I also wanted to show you up here. I'm going to do one other one really quick just to show you something. X to the 6th over x squared. I meant to show this before, and then I'll come back to my example and show you one other way. X to the 6th means I have 6 x's, and x squared means I have 2. So if I cross off the commonalities, I see that I have 4 left, and they're in the numerator. So 6 minus 2 is 4, and again, somebody just came up with the shortcut of subtracting the exponent so that you didn't have to write it out, as you see I did here. So what happened in number 2, as I was saying, was 40 and 4. Always remember that those are regular numbers that get divided. They are not exponents. That's why they became 10. But 4 minus 7 became negative 3, which then had to move down. Now, one other way to do this problem is 40 over 4, and Alex will allude to this as well, especially when it first introduces this topic. It is not going to teach you about negative exponents right away. It has you look to see where are there more x's. Well, there are more x's in the bottom, so the x should stay in the bottom. And then you would say to yourself, okay, there are more x's in the denominator. How many more? 3. And you'll notice this answer is the same answer I just got here, but I was actually applying rules as opposed to looking at where there's more. Let's look at another one. I'm going to do it both ways. Number 3 down here at the bottom. Sorry, I'm just clearing up my space here. 12 and 16. First, I need to figure out how to reduce that because 12 and 16 don't go into each other, but I do know that 4 goes into both. So I can divide the top and the bottom by 4. And I should have the 4 here, but I'm just showing you that I'm dividing by 4. 12 divided by 4 is 3. 16 divided by 4 is 4. So 12/16 is the same as 3/4. Now, if I use the rule of subtraction, w to the 5th and w to the 9th, I know that 5 minus 9 is negative 4. But again, you cannot have a negative exponent. So I would leave the 3 and the 4 where they are, and I would move the w to the denominator, just like that. And the other way to do it is just to look at it. Still make the 12 over 16 3 over 4. Say to yourself, where are there more w's? There are more w's in the bottom, so they're going to stay in the bottom. And the excess is what's staying in the bottom. So once I cross off essentially what they have in common, 4 is going to be left over. And I'm getting the same answer. Again, one, I'm using the rule of subtraction and having to remove the negative exponent. In the other one, it's more, I guess you could say, a common sense approach where you say you have more in the bottom, they're going to be left in the bottom. And this just shows there's more than one way to do an exponent problem, as long as you're following an appropriate rule. So let's look at a few more of these. Number 4 here. I have z6 and z4. So I'm going to do the subtraction. I get z squared. 2 minus 3, I'm sorry, that should be an x. z6, z4, 6 minus 4 is 2. 2 minus 3 is negative 1. But again, I can't have a negative exponent. So I would keep z squared in the numerator, and I would move the x to the first down to the denominator. Or you could just look at this problem and say there are more z's in the top, so the z will stay on the top. There are more x's in the bottom, so the x will stay on the bottom. And then you can figure out how many of each will stay where they are. So how many more z's are there in the top? Well, there are 2 more. And how many more x's in the bottom? 1 more, although I don't really need to write the 1. And that's the same answer I just got using the division rule. In number 5 here, I have 45 and 36. Both of these are divisible by 9. 45 divided by 9 is 5. 36 divided by 9 is 4. So I end up with 5 over 4. Now, if you prefer the rule where you notice there are more in the bottom of the u's, you should notice that there should be u squared left in the bottom because there are 2 more u's than there are in the top. Or for the u's, you would have gotten 1 minus 3, which is u to the negative 2 if you do subtraction. But remember that u to the negative 2 would have moved to the bottom anyways because you always remove negatives. When you subtract, it automatically puts what you're working with in the numerator every time. And if it becomes negative when you subtract, you would then be forced to move it to the bottom. And then for the v's here, I have 5 and 1. And I know that 5 minus 1 is 4. I have 4 v's left in the top, and this would be my final answer. Now let's take another look at one that uses multiplication and division property. So like the power rule where you have to multiply, I should say, let's look at one that uses multiplication of exponents and subtraction of exponents. Now, before you do the exponent on the outside, PEMDAS is involved here. So I personally would simplify everything I can on the inside. And what I notice is that x is going to become x to the 5th because I have more x's in the numerator. 7 minus 2 is 5. For the y's, when I do 5 minus 7, for the y's, I get y to the negative 2, which I could put up here next to the x, but because it's negative, I'm not going to actually leave it there. I'm going to stick that in the bottom. So I've simplified what's inside, and now I need to apply the 2 that's on the outside. So I end up with x to the 10th over y to the 4th, because remember when we have a power raised to a power or an exponent to an exponent, they get multiplied. 5 times 2, 2 times 2, and that would be your final answer. So that's a little brief overview of negative exponents and division. We're going to come back to them in a few minutes. I do want to say a few more things about one additional rule, which is the rule of 0. And you can always test this on a calculator, but any time in math you have a 0 exponent, a to the 0 is always 1. And I wrote this little expression over here for you. This it's a monomial because it's a single term. This entire thing on the inside, even though it has multiple pieces, it's raised to the 0. So the answer for this is 1. If I take any set of parentheses, it could have a million things inside, division, exponents, things that can combine. As soon as you notice the entire thing is raised to the 0, it automatically becomes 1. In this example here, they'll give you some practice with 0 rule. 5 to the, so exponents say PEMDAS, ready? Remember, order of operations say parentheses first. There's nothing I can do inside because all I have is a 5. Then exponents. So 5 to the 0, what is that? Well, 5 to the 0 is 1, and there happens to be a negative in front of it, in front of the parentheses, that is. So after I change 5 to the 0 to 1, that negative sign would just come over with the 1, making it negative 1. And then in this example here, if I follow exponents first, 7 over 9 to the 0 is just 1, and the negative 2 is attached to it. So my final answer here would be negative 2. A lot of times students think that something to the 0 is 0. Something times 0 is 0, but something being raised to the 0 is not 0. I also like to prove it to you another way. What would 3 to the 4th over 3 to the 4th be? Well, if you use the rule of subtraction, you would get 4 minus 4, which is 0. So 3 to the 4th over 3 to the 4th is the same thing as 3 to the 0. And what did we just say anything to the 0 was? 1. And also, if you go back to the original problem, hopefully you notice something here. The top and the bottom here match, which means anytime you divide something by itself, like 5 divided by 5, x divided by x, it automatically cancels out and becomes 1. because anything divided by itself is 1. So that's just proof that the rule to the 0 power does work. Now let's take a look at a couple last examples. I just have 3 or 4 left for this video, and then I'm going to move on to a new video topic. But this is going to finish up the rules of exponents here. So this is an introduction again to multiplication. So there's 3 pieces being multiplied. They use the dots again. I'm going to switch this to parentheses. Always feel free to do the same. Now we're going to deal with numbers. 4 times 2 is 8. 8 times 4 is 32. So 32. Now let's look at the v's. I have v to the -7 and v to the 2nd. This is multiplication. And through multiplication, exponents get added. -7 plus 2 is -5. W to the -1 and W to the 4 also get added for the exponents. -1 plus 4 is W to the 3. Did I account for all my letters? No, I didn't. I still have an X here. X to the -2 and X to the first, -2 and 1, is X to the -1. Just going to double check all of that. 4 times 2 is 8. 8 times 4 is 32. -7 for the V and -2 gave me -5. -1 and 4 gave me 3, and it's +3 because -1 plus 4. And for the X's, it was -2 plus 1, which is a -1. Now, if you enter this into ALEKS, there's 2 things you always want to look for. All of the variables should only appear once. Like in the original problem, I had a V here and here. That's how I know I wasn't done. But if I look this over, I only see 1 V, 1 W, 1 X. That's a good start. The other thing I have to look for, though, is to make sure I have no negative exponents. If I have a negative exponent, I am not finished. So I'm going to put this over 1. I am going to leave the 32 in the numerator, and I'm also going to leave the W to the 3 in the numerator, because the W3 and the 32, technically there's a 1 there, are not negative. They do not have negative exponents. But the V and the X need to be moved to the denominator because they both have a negative exponent. And when I moved the X down to the denominator, I did not put the 1 because it is no longer needed. Now here's a common mistake that people make with an example like number 4. So I have division here, and the rule for division, remember, is to subtract. I'm going to set this up a little different. Subtract the exponents. Well, what are the exponents? 3 and -6. So in essence, I'm doing 3 minus -6, but in math, we know that you cannot have 2 negatives touching like that. It actually changes to addition. So even though division we are supposed to subtract, there are a few instances where it will change to addition because I'm subtracting a positive and a negative in this example, and that negative 3 minus -6 ends up becoming 3 plus 6. So I get b to the 9th as my answer. I can prove it another way because I could have rewritten this problem as b cubed b to the 6th. In other words, I can take this negative and move it up next to the b and make it positive, because remember, if something is negative in the denominator, you can always move it to the numerator. So I did, and I don't have anything left in the denominator. And then how would I simplify this? Well, I know that when I'm multiplying, exponents get added, and I still get b to the 9th. I do find that most students will subtract, but then they have to watch out for that double negation. Now, what about an example like example number 5? So I have -6 take away 5, which is -11. I have 3 minus -1. 3 minus -1, which actually changes to plus in this example. For the b's, I end up with b to the 4. And I have -4 minus 9, which is -13. I look this over, I have 3 letters or 3 variables. 2 of them have negative exponents. I'm going to leave the b in the numerator, and the a and the c go to the denominator. And that is my final answer. And then I know that these get longer and longer, and the homework is pretty daunting for homework 9, but it's just because there's a lot of rules and they really require a great deal of practice, which is why there are so many topics in homework 9. Some of the problems are very short, so you'll get through them quickly. Others take a little bit more time. But I did want to do one problem where I pretty much apply all of the rules that we learned today with the exception of maybe the 0 may not come up. So in this first one, parentheses here, there's nothing I can do, and there's nothing outside. But I notice in the second parentheses, there's a -3 on the outside. So the first thing I'm going to do is I'm going to go through and put ones in. And I am going to leave the first set of parentheses exactly the way it is. I'm going to take the second set of parentheses and I'm going to raise all of these exponents to the -3rd through multiplication. So I get -3 in parentheses. Remember, numbers are a little tricky. You have to keep them in parentheses for the calculator purposes. But -3 is going to be to the -3. U is going to end up being to the -6. V is going to end up being to the -3. And W to the -9. Just like that. Now, there's a couple things you could do here. First, I'm going to simplify this -3 to the -3 just to get that out of the way. So 3 to the 3, or -3 to the -3. Well, actually, I can't do that yet. Let's see how I would do this next. There's a couple ways I could do this. All right, I'm going to keep that there for a second. Sorry, I should have looked to see how Alex does the next step, just so that if you click on the help button, I'm just going to put this back because I think that they would probably do something else first. I'm just rewriting it, bear with me. Okay, so ignore this for a second. All right, I'm going to rewrite this first one as 1 over, that's this first parenthesis. I left the W in the bottom, but I moved the U down, times. I'm also going to rewrite the second one, because if you look in the second set of parentheses, every single one of these has a negative exponent. So I rewrote the first fraction, moving down the U, which would leave the top empty. I can't leave it empty, so I put a 1 there. I also pretended there was a 1 under the second fraction, and I moved everything to the bottom. And now I would need to multiply the two fractions together. And to multiply two fractions, you do the top first, so 1 times 1 is just 1. I'm going to do this -3 to the 3rd now. So -3 to the 3rd is -3 times -3, which is 9, times -3, which is -27. The W3 is going to get combined with the W9. W3 times W9 is W12, because remember, through multiplication, exponents get added. U2 and U6 is U8, because 2 plus 6. And I only see one V, so I'm just going to leave V to the 3rd. And that would be my final answer. So in this particular problem, I had to multiply exponents, I had to remove negatives, and I had to add exponents in the denominator. So I didn't subtract any exponents in this particular example, but in some instances you will. So just remember, there are quite a few rules of exponents. Sometimes the exponents will get added, sometimes they'll get multiplied, sometimes they'll get subtracted. Anything to the 0 is always 1, and if you have a negative exponent, you need to remove it unless you're dealing with scientific notation. So I hope these examples helped you, and in the next video we'll be talking about scientific notation.